Good day, stats students. So today we're going to go over kind of like the introduction for chapter 10. So there's two sections that we're going to go over, section 10.2 and 10.4, and I need to kind of tell you the difference between between those two, so we kind of can get started here. So often researchers would like to compare two population means. So this chapter is all about the comparison of two population means. And so you might be asking, well, Doug, how can we have two populations? Because we've just been working with one population. How can we have two? Well, here's an example. Instead of looking at the height of all University of Akron students, the researchers wants to compare the heights of all University of Akron males versus heights of all University of Akron females. And so on average. And so notice there that we have simply two distinct groups that the researcher has defined. And so instead of looking at the, all University of Akron students, the researchers just decided to separate it between males and females. And so now we have two distinct groups. And so as long as we have two distinct groups that the researcher has defined, we have two populations. All right. So there's a couple of different ways that you can analyze data with regards to this. It just kind of depends on the situation. And so we have what's called dependent versus independent samples. And so I actually want to start with dependent samples. All right, so I want to start with dependent samples. So here's an example that you have the exact same people in both samples, and you have a before versus after situation. And so you might be asking yourself, well, how can I have a before and after situation where I have exactly the same people in both populations? Well, here it is. And so let's say that students took the SAT and they didn't do very well, and they wanted to improve their score. And so they took the course that would help them improve their SAT scores. And so notice here that you have the student's situation before they took the course. Okay, and so we would go ahead and measure their SAT scores then. And then we have exactly the same students. It's just that after they took the course. So something has kind of changed about them, right? Something has intervened. What has intervened? Them taking the course. Okay, and so we're going to compare their SAT scores before and after. All right, and so this is what we call repeated measures in statistics. We are just measuring the exact same people just at different times. That's it. All right. And this would be an example of dependent samples. Here, I'll give you another example where you don't have exactly the same people. You might actually have different people. And so let's say that we want to compare husbands and wives' annual salaries. By the way, in section 10.2 and 10.4, and when you do this in real life, it doesn't matter which one you call population 1 and population 2. Now, when you do the problems, we're going to set what population 1 and 2 is. Don't change it if we do that, okay? But in real life, it doesn't really matter. Okay, so let's say that we make wives population number 1. And so her salary is going to be compared to who? Her husband's salary, and only her husband's salary. There's no one else to compare it to if we're comparing husbands and wives' salaries. Okay, and so this is kind of the first situation where you had the SAT scores. So you got population 1, population number 2, and we took a random sample from each one. And so person number 1, their SAT scores are going to be compared to person number 1. It's just that it's after they took the course. And so that's why I have a line going straight across from person 1 to person 1, person 2 to person 2, person 3, right? The comparison can only be to themselves. It only makes sense. And in the situation where we had husbands and wives, so we have, looks like here, population number 1, the wives. Okay, so we got wife number 1. And so her salary, her annual salary, is going to be compared to one and only one person. Who? Her husband's, right? And wife number 2 is going to be compared to who? Her husband's, right? And so this would be a situation where we have different people, but we have this natural pairing going on. That's okay. This natural pairing going on. All right. And the one sample depends upon the other sample. So whoever's in the first sample, wife 1, wife 2, wife 3, wife 4, kind of dictates who then is going to be in the second sample. So the samples are dependent on one another. All right. Well, what about the independent samples case? So I'm down here at the bottom, okay, of the slide. It says no natural one-to-one pairing. All right, and so this would be an example of we want to compare University of Akron males versus University of Akron females somehow. All right, I don't know, GPA or something. At least on average. All right, and so think about it yourself. So let's say that you're a female. Is there one and only one male University of Akron male that you can be compared to? No, probably not. Okay, and the same would hold true for the males. There's no one particular female that you can be compared to. So I had a student raise their hand one time and says, "You know what? I have a twin. It was a female. She goes, I have a twin brother. What about that?" And I go, well, that would be fine if we were just looking at twins, but does everybody have a twin? And the answer is no. Okay. And so if not everybody has a natural pairing going on, you got independent samples. The samples are independent of one another. Okay, so whoever you brought in the first sample isn't going to necessarily dictate who's going to be brought into the second sample. Okay. So dependent samples is section 10.4. And it's what we call the paired t-test. You can imagine why we call it a paired t-test. Got all this natural pairings going on. Okay. And independent samples, that's section 10.2, and it's what we call a two-sample t-test. Two-sample t-test and a paired t-test. All right. So when we actually go through this, we're going to actually go through 10.2 first and then 10.4. All right. But before we get there, let's give you some examples. All right. So I used to watch this television show with my kids called Brain Games. So the television program did a study where they had 40 randomly selected adults drive a go-kart course, but the steering wheel actually steered the opposite way. So if you turn the wheel to the right, the car actually turned to the left and vice versa. Then they studied 40 randomly selected children from the ages of 10 to 12, and they drove the same course under the same conditions. The two population means were compared to see if a significant difference existed. So what do you guys think here? Is this independent or dependent? I'll let you think about it. I should play some Jeopardy music at this point. All right, so let's define a couple of things. What are the two populations? We got all adults and then all children from the ages of 10 to 12. That's our two populations. Hopefully you see that. All right. And then is this an independent case or a dependent case? Are we doing a two-sample t-test or a paired t-test? And hopefully you said that was the independent samples case. All right. So the adults that were randomly selected, that didn't tell us which children to go look at. Okay. And study. All right. All right. By the way, the children's mean time to finish the course was significantly lower than the adults because the adults had been driving for so long that it was hard for them, their brains to switch, when they needed to go right to turn the wheel to left. Well, the kids weren't driving yet. Notice that their ages were 10 to 12. And so it was easier for their brains to adapt. So anyways. All right. How about the second example? So one of my favorite shows of all time, Mythbusters, did a study in which the host did a series of cognitive tests in which they were timed. Then all the hosts were sleep deprived for 24 hours. After they were all tested again doing the same type of tasks. Again, they were timed. All right. The mean time before being sleep deprived and after were compared to see if even mild sleep deprivation increased the mean time to complete the tasks. Assume that the results could be applied to all adults. So, what's our two populations? We got all adults before and after sleep deprivation. As long as you feel like the host could, accurately represent all adults. Okay, I don't see why not. There was a mixture of males and females in there. Okay, and then two, is this the independent or dependence case? Is this the two-sample t-test or the paired t-test? And so, since we got this before and after, and that their times were compared to simply themselves, okay, before and after situation, we got the dependent samples, the paired t-test, okay? So, that ends hopefully you got that, and that ends our introduction for 10.2 and 10.4. So we're going to start with 10.2. So we will hope you have a good day, and I'll talk to you then. Bye.